Right, hello, welcome to another video. This is a continuation of the Oxford MAT series that I'm doing. This is episode number 4, I believe. It should be number 5, however, I fouled up in the production side. I uploaded the wrong video and then deleted the correct video, so a video that should have gone up hasn't gone up, which is a shame, but you know, what can you do? I'm just going to carry on and make some more of these videos. So this is another question from the 2020 Oxford Maths admission test. It says a square has centre 3, 4 and one corner at 1, 5, and then it wants to know where the other corners are at. So if we imagine our square, we draw our square, our centre has coordinates 3, 4, and our one corner, in terms of the x direction, it is less, so it goes this way, and our y direction is higher, so it goes this way. So we can kind of work out that the corner is kind of like basically here-ish. 1, 5. Oh no, I don't want to keep. Oh, for God's sake. Okay, so let's try that again. So 1, 5. So this line here, we can work out its gradient, we can work out its length, and then we can kind of use that to work out where the other 3 points are. So we can work out the length. So if we just go 5 minus 4 squared, which is 1 squared, 3 minus 1 squared, which is 2 squared. So our length is root 5. Well, to be fair, we can just go we can say we've gone 2 down and we've gone 1 across, and then we want to go 2 down and we want to go 1 across again. So kind of ignore the length bit there. But so if we've gone 1 to 3. 3 will now become 5, 5, 4, and then 3. However, that's not a point that is an option for us, so we're going to have to work out one of these 2 points here. And the way I thought was a good idea to do it was that if you imagine that the line from 1, 5 to 3, 4 is a equation in the form of y equals, if I'm going to change the colour of the ink just to make it a bit easier to visualize. So if we imagine that this line here is an equation, there could also be an equation for this line that goes through the center. It's not a very well drawn line, but is completely perpendicular to our original line and goes through our other 2 corners. So we can work out the equation of this line and then plug in the values given in the answers and see if any of them do fit. So first thing we want to do is we want to work out the gradient of our new line. So the gradient is the minus 1 over m form of the gradient from our original line. The gradient from our original line we can just work out as the difference between the 2 y coordinates and the difference between the 2 x coordinates. So we have 5 minus 4 over 1 minus 3. This gives us 1 over minus 2, or just minus a half. So therefore the gradient of our new line is going to be minus 1 over minus a half, which is 2. And in fact, I'm just gonna rub all of that off. There we go. Let's just finish that. That is a 5. So we know that the gradient of the line going like that is 2, and we know that it goes through the point 3, 4. So we can just use the formula y minus y1 equals m, x minus x1. So y minus y1, which is 4, equals 2 because our new gradient is 2, x minus x1, which is 3, and this simplifies to y equals 2x minus 2. So now what we can do is just plug in the values from a, b, c, d, and e, and we can just see if they work. So if the first one, 3 equals 2, 1, I've put in a bracket there unnecessarily, 2, lots of 1, minus 2, no joy. So then we try B, 5 equals 5, lots of 2, minus 2, that gives you 8, so no. C, 4, 2, so we have 2 equals 2, lots of 4, minus 2, that gives us 6, nope. We go to D, 2 equals 2, multiply by 2, minus 2, and that does give us 2. So our answer for this one is D. So the another corner is at the point 2, 2. So that's this video done. Thank you for watching, and I will see you in the next video.